Hi, this is Leetcode question, new 21 game. For this question, first of all we'll do big O of n square solution that will lead to TLE. Then after that we will do big O of n solution. Let's start with this one. Now here we have n equal 9 and max points equal 3. So we need to solve for all values from 1 to n. We have 1, 2, 3, 4, 5, 6, 7, 8, 9 is this table. Now the idea is assume that we want to solve for value 4, and we know that for 3 the solution or the probability is x, for 2 it's y, and for 1 it's z. Now 4 minus 1 point equal 3. So we know from 3 we can go to 4 if we draw 1 point, and that means for 4 we add the value. Let's assume it's initially 0, so 0 plus the probability of 1, because we are going from 3 to 4 by drawing 1 point. The probability of 1 is 1 over 3, which is the max points. So 1 over 3 is the probability to draw 1 or 2 or 3. Let's call this as P. So for 4, to go from 3, need 1 point, so it's P, which is the 1 over 3 multiplied by the solution for 3, which is x, plus. Now also we can reach 4 by going from 2. Let's say we are at 2 and we draw 2 points, so we can go to 4. That means also for 4 we need to add the solution probability of gaining the or drawing 2 points multiplied by the solution for 2, which is y, plus. Also we can reach 4 from 1. So if we are at 1 and we draw 3 points, that means we reach 4. So the solution for 4, we add probability of drawing 3, which is P again, multiplied by the solution for at 1, which is Z. So at the end we managed to solve for 4 based on the solution for the previous value. And so this is why we created this table, to use dynamic programming to solve this question. Now the same for 5, we can reach 5 from 5 minus 1 equal 4, so it's 0 plus probability of the solution at 4, it's TB of 4, plus probability of P multiplied by TB of 3, plus P multiplied by TB, which is the solution at 2. In this case TB of 3 is x, TB of 2 is y. Now notice, if we want to solve for value like 8, or 7, now 7 minus 1 equals 6, 7 minus 2 equals 5, 7 minus 3 equals 4. From 6, so to reach 7 we need 1 point from 6, but at 6 we already exceeds the value of k, so we cannot go from 6 to 7. So this is not part of the solution because 6 is already greater than k, and if we are greater than k we don't need to draw again. The same for this value, 7 minus 2 equals 5. Now 5 is greater than or equal to k, and so we don't need to add this to the solution. For 3, 7 minus 3 equals 4. For 4 it's less than k, in this case we add this to the solution. So for 7 it's the probability to get 3 points, which is P, multiplied by the solution for 4, TB of 4, and this will be the solution for 7. And for these we don't add it to solution because again these values are greater than or equal to k, and this is why we have this condition here. So let's solve it from the beginning. So initially the probabilities of the value 1, 2 and the 3 is p, which is 1 over 3. So we initialize all the value from 1 to max points to the value p, which is 1 over 3. Then we will start solving all the values from 2 from here, because 1 there is no other paths. This is the solution for 1. For 2 you can draw 2 points directly, or you can draw 1 then 1, so you can draw 1 and go from to 2. So the solution for 2 is p plus the probability to gain 1 point, which is p multiplied by the solution tb of 1. Now we are done with 2. Let's solve for 3. For 3 we have the value v plus. Now we can go from 2 to 3 by gaining 1 point, so p multiplied by the solution of 2, or we can go from 1 to 3 by gaining 2 points, so plus p multiplied by tb of 1. Now let's solve for 4. For 4 it's 0 initially, plus we can go from 3 to 4, p multiplied by tb of 3, or from 2 to 4 by gaining 2 points or draw 2 points, or we can go from 1 to 4. Now from 5 have 0 plus p multiplied by tb of 4 plus tb of 3 plus tb of 2. Notice we don't do tb of 1 because we cannot go from 1 to 5. Only we can do 1 point, 2 points or 3 points. Now for 6 the same, tb of 5 plus, so here p multiply, here p multiply, tb of 4 plus p multiply by tb of 3, and so on. So for 7, as we said, p tb of, so here for 6 we set tb of 5, but 5 is equal to k, so we remove this from the solution. We cannot go from 5 to 6 because 5 we already equal to k. For 7 tb of 6, but we cannot do 6, 5, 4. For 8 it's 0, for 9 is 0, and that's it. The final answer will be all the results from k, which is 5, up to n. So we sum these values here, and that will be the final answer. Now this solution give TLE because it's n square, and the reason for that, we are iterating. So for example, when we did 4, we went to 3, 2, 1, and we need to avoid this by using sliding window. And the idea is, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Now we will use the sliding window to solve this part, and we said initially 1 and 2 and the 3 have the value p, the other have 0. Now the idea of sliding window, since let's say we have this value w, which is the window of these 3 values. Now when we solve for 5, we just move the window to, or when we solve for 6, we move the window to cover these 3 values. So we take this part and we add this part. So the value of window initially 0, and here we are at 2. So 2, we said it's we add to w p multiplied by tb of 1. So now we add w to this, and for 3 we don't need to do loop again, we just add to this p multiplied by tb of 2. So this will be p plus w. For 4 we need to add p multiplied by tb of 3 to the window, and this will be 0 plus w. So this is the value of w. Now for 5 we need to add p multiplied by tb of 4 to the window, but now also because the window is with the length of max points which equal to 3, so we take these 3 values and we need to remove this from answer. So we do minus p multiplied by tb of 1, which is just we remove this from the solution, and we add w. So the w is these 3 values. Now notice that we are take advantage of the previous solution to solve for the current iteration. The same for 6. For 6 we add p multiplied by tb of 5, but notice that we said we cannot go from 5 to 6, so this is not part of the solution. And we take the first value for the window, so the window is this length 3, and we remove the first one, so we have w minus here this value, and we do the plus here, and we assign this to the solution. And notice that in this condition I minus max points greater than k break. For example, if we are solving for 7, so 7 we have choices or 8 minus 1 equals 7, 8 minus 2 equals 6, 8 minus 3 equals 5. So this value 5 is greater than or equal to k. In this case we break, and the solution for 8 is 0. And at the end we loop from k until n to have to accumulate our answer. The solution time complexity for this solution is big O of n.